All right, hi everybody. We're working through the radicals chapter here, and what we're trying to do here is find or put this quadratic through the radical transformation. First thing we want to note here is that we're going to lose all of this that drops below the x-axis. Okay, because anywhere where the y-coordinate, okay, or the function becomes negative, I can't take the square root of that. Now, where it crosses the x-axis, the y-coordinate is 0, which means those points are going to stay invariant. Okay, those aren't going to change here. So it turns out the x-intercepts of the original stay the x-intercepts of the transformed, and in that case this is going to be 1 and 5. Additionally, any point where the y-coordinate goes to 1 is also going to stay the same because the square root of 1 is 1. And remember, it's the y-coordinates we're taking the square root of here. So now I might look for one other point here. I know that the y-intercept of this graph here is positive 5, which means the y-intercept of the transform graph is going to be root 5, which will be slightly over 2. So I can say right now that the y-intercept here is going to be root 5, whatever that decimal turns out to be. Now, this section right here, where the y-coordinates are fractions, when you take the square root of it, the square root is going to cause the function to bubble out above the line. Because when you take the square root of a fraction, the result gets bigger. As soon as we cross that invariant point, we're dealing with y-coordinates that are now bigger than 1, and so all of the square roots will get smaller, and so this will go up like that. Over on the right-hand side, we're going to see a symmetric sort of behavior here. Sorry, you get the idea. That probably didn't draw out as nicely as I would have liked, but you get the idea. And so the domain here is going to be that x is going to be less than or equal to 1, together with x is greater than or equal to 5. The range, okay, because this is going to keep going up and up here, the range will be y is greater than or equal to 0. And like the previous question, the number of invariant points that I have here are the number of places where the y-coordinate goes to 0 or 1, and that's going to be 4. Now, before I leave this question, just one quick little note here. It is incorrect to write the domain like this. 5 is less than or equal to x is less than or equal to 1. Now, I know that this carries with it those two bits right there, but this suggests that the values of x for the domain are simultaneously bigger than 5 and less than 1, and there's no number that does that. There are two parts to the domain of the function here from the graph, which means when we write out the domain, there should be two distinct expressions to express the domain. So if you just kind of keep that connection here, if you see two branches to the function that are disconnected, there should be two distinct branches to the domain as well.